Alright guys, today we are going to be looking at problems where we are going to have to use the FOIL or box method, and then after we do that we will have to factor these quadratics in order to find our solutions. So go ahead and pause this video here and copy down the notes that I have written. Up top here I just have reminders about foiling, how we FOIL, and then also reminders about the box method and using those. Either way we can see that we're getting to the same solution. It just depends on which method you prefer. Today I'll be using the FOIL method. So just know that if you're using the box method, if that's the way that you prefer to use, you'll also get to the same thing. But let's go ahead and look at number 1 here. So I have x underneath my radical and I have x over here, and we want to go ahead and find the solution. But knowing that I have a radical, because I'm subtracting 5 on this right side here, I want to go ahead and isolate this radical so then I'll be able to undo it. So I'm going to go ahead and add 5 to the other side. Now, seeing how x and 5 are not like terms, I'm going to go ahead and get x plus 5 equal to, these cancel, and so I'm left with the square root of negative x plus 1. And then again, we want to go ahead and get rid of my radical. And like what we've been working on all week, to get rid of a radical and to isolate it, we undo our radical by raising it to a power. And so here on the left side, what's a little bit different is because I have x plus 5, I want to keep this all together as one group and raise this all to the second power. So remember, when we have something to the second power, it's really like we have 2 of them. So I have x plus 5 times x plus 5 equal to, over here on the right side, my squared and my radical cancel, and I'm left with negative x plus 1. All right, so we've got a lot of x's here, but we want to go ahead and keep following our rules of solving. And so now, as you can recognize, like what we have up top here, we have our FOIL or our box method. You can kind of set up whichever one works best for you. I'm going to go ahead and FOIL this left side here. So I'm going to take my first term and I'm going to multiply it by both in my second term. So I'm going to get x squared plus 5x. And then I'm going to take my second term here and multiply it by both in my second group. So then I'm going to get 5x plus 25. Still equal to negative x plus 1. Now, hopefully you're recognizing this x squared here is telling you that we have a quadratic, and we want our quadratic set equal to 0. Okay, so I need to move my negative x and my plus 1 over to the other side by doing the opposite. So when I combine all of my like terms here, I get x squared, 5x plus 5x plus x will get me 11x. And then 25 minus 1 will get me 24, all equal to 0. So again, I just combine my like terms to get my whole quadratic set equal to 0. From here, now we can go ahead and factor, which, if you remember, that's when we use our t-chart. What multiplies to get us a times c, which would be 24. That will also add to get us our b value of 11. So thinking through our options of what works for this, hopefully you're thinking 3 times 8 gets me 24, and it also adds to get me 11. So now I can go ahead and rewrite these as our factors. So I have x plus 3 and x plus 8 equal to 0. So to solve and get x by itself here, I'm going to go ahead and take each factor, set it equal to 0, and then solve, which most of you guys do this part in your head. We just automatically flip it. So I get x equals negative 3 and x equals negative 8. So again, our last part that we need to do, we've got to our answers. Okay, and the last part that we need to do is to plug these back in to our original to make sure they work. Now, for saving of time, I already worked this out. Okay, and so taking a look at this, I went and took x equals -8 and x equals -3, and I plugged them back into our equation. When I plugged in -8, take a look at what happened here. I got -8 equals -2. This is not true. So x cannot equal -8. That would be an extraneous solution. That's not part of my answers. But when we plug in -3, this one works out. -3 equals -3. So my answer to this one is just x equals -3. All right, we have one more problem that we're going to go ahead and look at. Remember, you can pause the video at any point if you're getting stuck or if I'm going too quickly. All right, let's go ahead and look at number 2 here. So now I have x equals my square root of 24 minus 2x. Again, I want to get x by itself, and I have an x underneath my radical, so I need to go ahead and get rid of this radical here. So I'm going to go ahead and raise this side to the second power, and I'm going to go ahead and raise this side to the second power. Well, x to the second power is the same thing as just having x squared, equal to my squared and my radical cancel over here, so I'm left with 24 minus 2x. All right, this is very similar to what we were dealing with over here on the left. See how I had my x squared? I knew I was dealing with a quadratic, and I want my quadratics always set equal to 0. Notice how over here we took our terms and we moved them towards our x squared because we always want to have a positive x squared here. So I'm going to do the same thing. I'm going to take my 24 minus 2x and I'm going to move it towards my x squared here. So I'm going to subtract 24 and I'm going to add 2x. So these are going to cancel over here. And my new equation that we get x squared plus 2x minus 24 equal to 0. So this is now our quadratic that we have set equal to 0. And if you put them in a different order, that's okay. I just put them in standard form because I know it's going to help us with our next step here for factoring. So again, one more time, undid my radical by squaring both sides. Recognized that I had a quadratic, so I knew I needed to get it set equal to 0. So I moved my terms towards x squared, got to my quadratic here where we're set equal to 0. Now I can go ahead and jump to our step where we can factor this. So again, what multiplies to get me negative 24, that will add to get me a positive 2. Hopefully you're thinking 6 times negative 4. That multiplies to get me negative 24, but it adds to get me a positive 2. So now these become our factors. X plus 6, x minus 4 equal to 0. And for most of you guys, again, you do this next part in your head and you just flip it. But essentially what we're doing, we're taking each factor, we're setting it equal to 0. And so we get x equals negative 6 and x equals positive 4. Again, we need to check our answer, make sure that we see if any of our solutions are extraneous. So we want to take these two answers, go back to our original equation and plug them in for x. And again, to save time, I did this already for us. So when we plug in negative 6, when we simplify this, we're seeing we get to the end and it says negative 6 equals 6. This is not true, so this is an extraneous solution. This cannot be part of my answer. However, when we plug in positive 4, when we go ahead and simplify this, we get to the end where 4 equals 4. This is true, so x equals 4 would be my answer for this problem. All right, guys, these problems are a little bit longer and they do incorporate quite a few skills that you have learned, not only in Algebra 2, but also all the way back from Algebra 1. So take your time on these problems, reference back to this video if you need help on the practice for today. But these are the trickiest problems that you will see for 723. Because these ones are just simply the longest. If you have any questions, please make sure you reach out during my office hours or send me an email or a remind text. All right, guys, have a good rest of your day.